we have to prove Wheatstone Bridge principle. In the diagram, four resistances P, Q, R and a galvanometer form a quadrilateral ABCD. Four resistances P, Q, R, S form the quadrilateral ABCD, and a galvanometer of resistance G is connected between the two terminals B and D, and a battery is connected to this quadrilateral and along with a key K. Four resistances P, Q, R and S connected. Four resistances P, Q, R and S are connected to form a quadrilateral. Four resistances P, Q, R and S are connected to form a quadrilateral ABCD. A quadrilateral ABCD. A galvanometer of resistance G. A galvanometer of resistance G. Galvanometer of resistance G is also connected between the two terminals B and D. Is connected between the terminals between the points B and D of the circuit. Between the points B and D. Well, a battery of EMF E and a key a one-way key K are connected to this quadrilateral between the 2 points A and C. Are connected between the points between the 2 points A and C. Between the 2 points A and C. To form Wheatstone Bridge. To form a Wheatstone Bridge. A galvanometer of resistance G is connected between the 2 points B and D, while a battery of EMF E and one-way key K are connected between the 2 points A and C to form Wheatstone Bridge. Now a constant current I is generated from the battery of EMF E, and this constant current will be flowing through the quadrilateral in this way, and it will terminate to the cell of EMF E. Through the resistance P, existing between the 2 points A and B, a current I1 will be flowing. A current I1 will be flowing through the resistance P connected between the 2 points A and B, and remaining current I minus I1 according to Kirchhoff's current law. Remaining current I minus I1 will be flowing through the resistance R between A and D. A current Ig will be flowing through the galvanometer G. Remaining current, that is I1 minus Ig, will be flowing through the resistance Q from the point B, that is also according to Kirchhoff's law, and through the resistance S. A current I minus I1 plus Ig will be flowing. Let I be the current. Let I be the current or main current generated from the electric cell of EMF E. I be the current or I be the main current generated from the electric cell. Or from the battery of EMF E. From the battery after pressing after closing the key K, connected to the battery of EMF E. Now, if the plug is inserted in the key K, in that case the circuit will be closed and I amount of current will be flowing in this way from the battery. If a current I1 flows through the resistance P connected between the 2 points A and B, I1 flows through the resistance P between connected between the 2 points B and A and B. Then, according to Kirchhoff's current law, KCL, according to KCL, that is using Kirchhoff's current law, the remaining current I minus I1, remaining amount of current I minus I1 will be flowing through the resistance R. Remaining amount of current, that is the current I minus I1, will be flowing through the resistance R connected between the 2 points A and D, through the resistance R, capital R. Similarly, the currents flowing through the resistances the currents flowing through the resistance is Q, comma galvanometer G and S. Currents flowing through the resistances Q, comma G and S will be I1 minus Ig, comma Ig and I minus I1 plus Ig respectively, plus Ig respectively. Using Kirchhoff's voltage law, in the closed loop ABDA, we get, using Kirchhoff's voltage law in the closed loop ABDA, we get I1 into P plus Ig into G minus I minus I1 into R. I minus I1 into R equals 0. Or comma. So in the diagram, we are considering the loop ABDA. We were considering the loop ABDA in this direction. And if we travel from ABDA in the direction ABDA, first potential drop will be I1 into P, then potential difference will be Ig into G, and potential difference across the resistance R will be minus I minus I1 into R. Because we are traveling from D to A, but current I minus I1 will be flowing in the opposite direction. We are I minus I1, the current I minus I1 is flowing from A to D, and we are traveling from D to A. That's why this potential difference, that is I minus I1 into R, will be negative. Minus I minus I1 into R. This is negative. So, or I1 into P plus Ig into G equal I minus I1 into R. This is equation 1. I1 into P plus Ig into G equal I minus I1 into R. This is equation 1 that is derived by using Kirchhoff's voltage law in the closed loop ABDA. Third potential drop, that is I minus I1 into R, will be negative because we are traveling from D to A, but the current I minus I1 is flowing in the opposite direction. That's why this potential difference I minus I1 into R will be negative. Again, using Kirchhoff's voltage law in the closed loop, using Kirchhoff's voltage law in the closed loop BCDB, we get, in the closed loop BCDB, we get I1 minus Ig into Q, I1 minus Ig into Q. This is the first potential drop or potential difference in this loop BCDB. The next potential difference is I minus I1 plus Ig into S, and this is negative. And then Ig into G is also negative, minus Ig into G. In the loop BCDB, if we travel along BCDB, first potential difference is I1 minus Ig into Q. I1 minus Ig into Q. That is positive because we are traveling from B to C and current I1 minus Ig is also flowing in the same direction. But we are traveling along CD, but current I minus I1 into Ig is flowing in the opposite direction. That's why the potential difference across the resistance S will be negative. That means minus I minus I1 into Ig into S will be negative. We are traveling along BD, but the current Ig is flowing along BD, but we are traveling from D to E. That's why Ig into G will be negative. Ig into G will be negative. And I minus I1 plus Ig into S will be again negative, because current I minus I1 into Ig is flowing from D to C. I minus I1 into plus Ig. I minus I1 plus Ig is flowing from D to C, but we are traveling from C to D. C to D. That's why this potential difference is negative. Or comma I1 minus Ig into Q minus Ig into G equal I minus I1 plus Ig into S. This is equation 2. We get the equation 2 after using Kirchhoff's voltage law in the closed loop BCDB. This is equation 2. Equation 2. When the bridge is balanced, when the bridge is balanced, comma, the galvanometer shows no deflection, galvanometer G shows no deflection. That means no current will be flowing through the galvanometer of resistance G. When the bridge is balanced, comma, the potentials at the points B and D will be same. When the bridge is balanced, the potentials at the points B and D will be same. That means equal. Therefore, hence VB equal VD. Potential, electric potential or voltage at the point B and D are VB and VD, and VB equal VD. And no current flows through the galvanometer of resistance G. No current flows through the galvanometer of resistance G. Flows through the galvanometer of resistance G. Therefore, Ig equals 0. Current flowing through the galvanometer of resistance G will be 0. That is Ig equals 0. Using putting these values of Ig, that is Ig equals 0 in equation 1 and 2, putting this value, that is Ig equals 0 in equation 1 and 2, in the equations 1 and 2, 1 and 2, we get equation 1 was I1 into P, Ig into G equal I minus I1 into R. So Ig will be 0 in this equation. Putting Ig equals 0 in this equation, I1 into P plus Ig into G, and also putting Ig equal to 0 in equation 2, in equation 2 and in equation 1, we get I1 into P equal I minus I1 into R. I1 into P equal I minus I1 into R. And I1 into Q equal I minus I1 into S from equation 2. We get I1 into P equal I minus I1 into R from equation 1, and it can be denoted as equation 3, which is derived from equation 1 by putting Ig as 0. Similarly, from equation 2 we get I1 into Q equal I minus I1 into S, which is equation 4 derived from equation 2 by using the condition of using the balance condition of the bridge. Dividing equation 3 by equation 4. Dividing equation 3 by equation 4, we get I1 into P divided by I1 into Q, I1 dot P divided by I1 dot Q equal I minus I1 dot R divided by I minus I1 into S or dot S. Therefore, if we simplify, then therefore P by Q equal R by S. This is the final result in connection with the balance condition of Wheatstone Bridge. P by Q equal R by S. That means ratio of the resistances above the galvanometer, which is P by Q, will be equal to the ratio of resistances below the galvanometer, which is R by S. That means we get P by Q equal R by S. If P by Q equal R by S, then balance condition will be obtained. Potential at the point B and P will be same. No current flows through the galvanometer, that is Ig will be 0, and we get P by Q as equal to R by S. Hence, Wheatstone Bridge principle. Hence, Wheatstone Bridge principle Wheatstone Bridge principle is proved.